All right, using vertical angles theorem, we can conclude that angle ACB is congruent to angle DCE by the vertical angles theorem. You can reverse the order. You could call it ECD or BCA, but you can't just call it angle C and angle C because that lacks clarity as to which angle you're referring to. So just make sure you're using 3 letters in cases like this. Okay, reflexive property allows you to claim that something's congruent to itself. So GI of the left triangle has to be congruent to GI of the right triangle. Okay, if we have a midpoint, so K is the midpoint of JL, that means that we can conclude that this segment's congruent to that segment by definition of midpoint. So JK is congruent to KL by definition of midpoint. Then we have angle GI, right, is bisecting this angle. That's the angle that's being cut in half. So FIH is cut into 2 smaller congruent angles. So that would be angle FIG would be congruent to angle GIH by definition of angle bisector. Okay, if we have alternate interior angles, right, that's only going to present itself with parallel lines. So if we think about extending these parallel lines, cutting them by this transversal, right, we have that these are alternate sides of the transversal, but in the interior of the parallel lines. So we can conclude that those would be congruent. Similarly, if we have parallel lines, right, alternate interior angles is an option, but corresponding angles would be an option as well, right? Those are both in corresponding locations, right? They're both in the top right-hand corner. So those angles would be congruent to each other. Notice you can call this just angle J because it can't be confused for anything else, but you're going to have to use 3 letters to talk about this angle because angle K is too broad of a description. All right, we can conclude that right angles are congruent. So we're told M and N are right angles. Okay, that means that angle N must be congruent to angle M because all right angles are congruent. Then we have CPCTC. So you can use CPCTC once you have proven that 2 triangles are congruent. If you have proven that 2 triangles are congruent, you can make the claim that any of their corresponding parts are congruent. So corresponding parts of congruent triangles are congruent. Since I've stated that they are congruent, I can state that any of their corresponding parts are congruent utilizing this theorem. All right, so we have 5 ways that we can prove triangles congruent. Okay, side, 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 marking, adding in the 1 marking that would allow us to make the conclusion. Side, angle, side, notice the angle is in the middle of the 2 sides, so that needs to be the case inside of the diagram. Angle, side, angle, notice the side is in between the 2 angles, so that needs to be the case in the picture. And then angle, angle, side. Notice the side is not in between the 2 angles. Okay, it's just next to this one. Hypotenuse leg. Well, we have a leg, we have a right triangle. So if we were to know that the hypotenuse are congruent, we could make that conclusion. All right, so fill in the blanks, name the other triangle, and then give a reason why you believe they are congruent. So let's see, angle A would correspond with angle F. B would correspond with E, and C would correspond with D, and this would be by side, angle, side congruence. Okay, this one, we have angle, side, angle. Let's see, angle A corresponds with angle E, B corresponds with F, C corresponds with D. Triangle ABC. Let's see, we have angle, angle, side, angle, angle, side. Notice the side is not located in between. A corresponds with D, B corresponds with E, C corresponds with F. Down here we have angle, side, angle. A corresponds with F, B corresponds with E, C corresponds with D. This one we have angle, angle, side, angle, angle, side. Notice the side is not in between the angles. Angle A corresponds with angle F, B corresponds with angle E, C corresponds with angle D. And last case we have by side, side, side. Angle A corresponds with F, B corresponds with E, C corresponds with D. All right, last section says use the given information to mark the diagram, then determine whether we can prove the triangles are congruent. If so, which postulate or theorem would prove it? So angle A is congruent to angle E, that's given and it's marked. C is the midpoint of BD, so BD has been cut in half. And the only other thing that we could mark inside of this diagram are vertical angles. So we have angle, angle, side. So let's see, angle A corresponds with angle E, B with D, and C with C. On this one, angle A congruent to angle E, that's already marked. C is the midpoint of AE, so now it's this piece that's being cut in half. And we still have vertical angles. So now the triangles are congruent by angle, side, angle. Angle A goes with E, B goes with D, C goes with C. And last case, segment FG is congruent to segment GH. That's already marked. GI bisects this angle. Remember, I like to circle whatever comes after the word bisect because that's what's being cut in half. So this big angle was cut into two smaller angles. And then we have a shared side. Now this is angle side side. Angle side side is not a theorem, so we cannot prove that these triangles are congruent.